All right, we're back with the second part of this unit review. Don't forget to comment, like, and subscribe. Gonna be a free giveaway in class if you comment, like, or subscribe. So we're starting with standard 2.2. So this is those inequalities and absolute value equations and inequalities. So number 11, we have solved this now. It's an or inequality. So right away, we know what this should look like. Or it's going to be going out in two separate directions, right? I know one going this way. I know one going this way. We already know that, right? Now we just got to figure out what are these numbers, right? What are these numbers, where they're going out from. So this, don't overcomplicate it. All you do is solve these two separately, right? So here we subtract 2 from both sides. 3x is less than 0. Divided by 3. So that means x has to be less than 0. Okay. Then over here, right, add 3 to both sides, add 3. 2x is greater than 6. Divide by 2, divide by 2. X is greater than 3. So x, in order to make this thing true, has to be less than 0 or greater than 3. So if we think about the one that's less than, that's this guy over here, so that would be the 0. The one that's showing greater than, that's this one over here, so that would be our 3. Now, if you think about it, that makes sense, right? The 0 comes before 3 on the number line. So this all checks out. Cool. Then, if we look at number 12, okay, now we have an and inequality, right? Trying is one thing. So again, we know this already before even doing it, what this should look like. This should be on the inside, one connected piece on the inside. But let's figure out why. So we have this thing, ew, fractions, gross. Let's get rid of the fractions. So we're going to multiply everything by 3, where 12 is less than or equal to 5x plus 3 is less than 21. Subtract 3 from all 3 pieces, right? It's not just 2 sides now, it's the middle and the 2 ends. So we'll have 9 is less than or equal to 5x is less than 18. And then we'll divide that by 5. Everything by 5, and we'll get x in the middle, and we'll have 9/5 is less than or equal to x is less than or equal to 18/5. All right, so we solved it. Now we just got to graph it. So, right, we already knew it was just going to be one connected piece in the middle, but now we know a little more information, right? It's starting at 9/5, and in that case, because it's or equal to, right, we'll have a closed circle, and we now know that this over here is 18/5, and then, well, in this case, right, it's strictly less than, no or equal to, so this one will be an open circle. So in this case, a solution to our first inequality would be any number in between 9/5 and 18/5. Any number between 9/5 and 18/5. All right. Then we have an absolute value equation. So on these last two, right, we have infinite number of solutions. Any point on this line, right, any point in between here would make that inequality true. For the last one before that, right, any of these points would make that inequality true. For absolute value, it's not an infinite number of solutions. We either have 2 solutions, right? We're going to find 2 solutions, but then when we plug them in, we may have 2, we may have 1, we may have none. So we got to isolate this absolute value first. Remember, think of this as sort of like a box. You want to get rid of everything that's not inside the box. So we subtract 10, and we have 3 there. All right, then once the absolute value is isolated, we got to write our 2 equations. So the first one is we just get rid of the absolute value, right? So it'd just be 1 minus 1/5 x equals 3. The second one, we switch that piece that was outside the absolute value, we switch that to negative. Right, so that'd be negative 3. And then we just solve these 2 equations. So multiply both sides by 5, or both sides by 5. We have 5 minus x equals 15. Subtract 5 from both sides. So here we have negative x, don't forget that negative, equals 10. So x equals negative 10 would be one possible solution. right? Then the other one, we do the same thing. Multiply both sides by 5. We have 5 minus x equals negative 15 in this case. Subtract 5 from both sides. We'd have negative x equals negative 20. Divided by negative 1, x equals 20 is our other possible solution. But now we have to check these. And you can just do this on your calculator, right? So we have 1 minus 1/5 x plus 10 equals 13. We have to plug in negative 10 and 20 and see if those are true. So go to my calculator. Let's clear this out. Then we go to get that absolute value, math. And we go over to number, and it's that abs button. So abs. That'll put in our absolute value. We have 1 minus 1/5. Oops, 1/5 x. Let's start with the negative 10. And then we have plus 10 on the outside. And now if we're correct, let's get that. There we go, plus 10 on the outside. Now if we're correct, when we push enter, this should give us a 13. Because if we look back to the equation, it says equals 13. So let's look. Push enter. Ooh, so that means that negative 10 is a possible solution. Then we want to do the same thing, but instead of negative 10, we want to put a 20 in there. So we'll go over, put 20, not 200. Cool. Enter. Also gives us 13. So in this case, both of these, negative 10 and 20, are possible solutions because they both were true. Okay. And so then number 14. So number 14, same idea. In this case, the absolute value is already isolated for us, so we can start with just 12 minus 3x equals 2x. 12 minus 3x equals negative 2x. Then this, we want to get the variables together, so I'd start by adding 3x to both sides. We'll have 12 equals 5x. Divide by 5. X equals 12 over 5 is one of our possible solutions. On the other side, again, start by adding 3x. So we have 12 equals, well, negative 2x plus 3x is 1x, or just x. So our other possible solution we get right away. X equals 12 would be our other possible solution. Again, you have to check these. If you don't check these, you're probably going to get some points off. So in this case, if we plug in this 12 over 5, we're, if we plug in that 12 over 5, let me go to my calculator. So we would have, forgot, what was it? 12 minus 3x. So you go absolute value. So again, that's math, number, abs, 12 minus 3 times that first one, so 12 over 5. That gives us 4.8. Then we got to figure out the other side of the equation. So that 2x, so we got to do 2 times 12 over 5. So if this is a solution, it should also give us 4.8. And it does. So this first one is in fact a solution. Great. Now let's check that 12. So we got to do math, number, abs, 12 minus 3 times 12 will give us 24. And then if we do 2 times 12, hopefully we don't need our calculator for that one. That will also give us 24. So this one also checks out. So number 14, again, we have 2 solutions. We checked them both, plugged them in. They were both true. All right, now solve and graph this inequality. Now, first we want to isolate our variables. Isolate our absolute value. So here we have to add 5 to both sides. Make sure you do this before you write the inequalities, right? Before you separate it, you have to isolate. Otherwise, one of them is going to be incorrect. So we've isolated. Now, this is less than. So less than, that means we have one connected piece. Right, we're going to have one connected piece, and in this case, it's going to be closed circles. We got one connected piece with closed circles. We already know this, right? So since it's one connected piece, we can actually write one connected inequality. Right? We'll have one connected inequality with that 4 minus x in the center. 8 over there, and negative 8 on the left. All right, now let's get the x alone. So we subtract 4. So that'd be negative 12 is less than or equal to, don't forget that negative, x less than or equal to 4. Then we divide everything by negative 1. And when we do that, don't forget those inequalities flip. So we have 12 is greater than or equal to x is greater than or equal to negative 4. So which of these numbers comes first on our number line? That would be negative 4. And we have 12. So we have our solution, and we have our solutions graphed. All right, so any number between negative 4 and 12 would be a possible solution. All right. Number 16. Similar. Here, it's already isolated for us, which is nice. So we got to write our two inequalities. This one is greater than. So greater than, again, we can already know what this is going to look like. This is going to be two separate pieces. All right? Greater than is two pieces going outwards. So we have this one, and we have one over here. Now I got to figure out what those numbers are. So since it's two separate pieces, we have to write two separate inequalities. The first one is we leave everything the same, we just get rid of the absolute value. Second one, second one, we switch the inequality and make that outside negative. And then we got to solve this thing. So again, I would get rid of fractions, so I'd multiply everything by 3. We have 6 minus 9x is greater than or equal to 2. Subtract 6, so negative 9x is greater than or equal to negative 4. Divide by negative 9, notice the emphasis on negative there. So that would become x is less than or equal to 4/9. All right, we divided by negative 9, so that inequality's got to flip. And on this one, same steps. Multiply everything by 3, so 6 minus 9x is less than or equal to negative 2. Subtract 6 from both sides, negative 9x is less than or equal to negative 8. Divide by negative 9, negative, so that will become x is greater than or equal to 8 over 9. So this makes sense. If you didn't flip those, you would have a weird looking graph. Right? If you graph these two things, you'd have a weird looking graph that wouldn't be two going in different directions. Here, right, 4/9 comes first because 4/9 is smaller than 8/9, and since we want less than, its numbers off in this direction, right, which is what we had. Then 8/9 comes second on our number line, and since it's greater than 8/9, our arrow is going out this way. So notice, if you didn't flip those when you divided by negative 9, your graph wouldn't look like this. You'd have a weird looking graph. Great. We got 4 more, I believe, or 3 more. 17, 18, 4 more. Poof. It's been a long week. So the inflation of a regulation NFL football is 13 psi. That is what it should be, with a 0.5 psi tolerance. Write an absolute value inequality that represents the acceptable pressures of an NFL football. I think this was Mr. Myers trying to make a joke about the Patriots. But let's see. So here, let's remember it. You want the actual minus the ideal inside the absolute value. And the reason we want it inside the absolute value is because, again, it doesn't make a difference if you're too high or too low. We're just trying to figure out if you are wrong. All right, is less than or equal to the tolerance, which again is how wrong you're allowed to be. So in this case, if we're going to write an absolute value equation, if we choose a random football, we don't know its inflation, so we'd have x there. Less than, the ideal is 13. Less than or equal to that tolerance, 0.05. Oh, just not 0.05, just 0.5. Great. And then it doesn't say to solve, so this is all we got to do. That was easy. Moving on. Number 18, you need to drill holes in a piece of wood for making a cabinet. The specifications indicate that the diameter of the hole should be at least 0.5625 and at most 0.6875. Write an absolute value inequality that represents the acceptable diameters of the circle. So here, this is a little different, right? We still want that actual minus ideal inside the absolute values, less than or equal to tolerance. But here it doesn't tell us the ideal and the tolerance. We got to figure it out. So it tells us that the lowest fish should be 0.5625, right? That's the lowest possible. And that the highest possible is 0.6875. So here it tells us the range, and we have to figure out the ideal and the tolerance. Now remember, the ideal, if you think about it visually, is right in the middle here, right? So to figure out that ideal, we just got to average these two numbers. We got to average the high and the low. So our ideal is going to be 0.5625 plus 0.6875 divided by 2. So I don't know that is in my head. Let's go to the calculator. So we got to do in parentheses 0.5625 plus 0.6. I already figured out what it is. 875. Close parentheses divided by 2. So the ideal diameter of the hole would be 0.625. 0.625. And in this case, it's inches. 0.625 inches is our ideal. 0.625 inches is right in the middle there. Then to figure out the tolerance, remember that's just this distance from the high to the low. Or sorry, from the high to the ideal, which is the same thing as the distance from the ideal to the low. So here we have a few options. I'm just going to do the highest amount minus our ideal. So our tolerance would be our highest amount, so 0.6875 minus our ideal, 0.625. So our tolerance is going to be, let's go to the calculator, 0.6875 minus 0.625, 0.0625. So our tolerance is 0.0625. And then finally, we just have to plug that information in. So the absolute value inequality would be the absolute value of x minus our ideal, which is 0.625, is less than or equal to our tolerance, 0.0625. Great, and that would be our solution. Great. Oh, I thought there were 20 questions. Apparently there were only 17, so this video is shorter than I thought it was going to be. So email me if you have any questions. Otherwise, have a great weekend. Make good choices. Don't do anything I wouldn't do. And don't forget to like and subscribe. See you on Tuesday.